Hi, I'm Tom and I talk about code. Welcome to a PlayStation 2 game modding live stream. This is a bit different. Today we're going to be diving into Kingdom Hearts on the PlayStation 2, Kingdom Hearts Final Mix, specifically the superior version of the game. I'm going to be writing some C code and trying to inject it into the game. Now I've already got some tools that I've written previously that allow me to unpack all the files. We can have a look at that actually. We can quickly just have a little so basically I've got this script. Let's look at this bin patch script that I just wrote. We're going to apply a patch. We currently don't have a patch. We've got a bunch of commands with a bunch of tools that I've written. These will run in Go. We can dump out the index. And so I ran this just before. So if we look at temp wp index.json, let's look at it through JQ. Let's look at it through... What? Oh, right, we have to CAD into JQ, don't we? Cool. So this is a list of all the files in the game. We can use this index, we can unpack files, we can repack files. So this is kind of cool. So I can unpack the binary, I can do all kinds of fun elf modifications, I can apply binary patches. Awesome. So let's do that. Let's write some code that we're going to load into the game. We're going to use my special binary patch that I've written that messes around with data in the elf. It loads, basically it dumps some code into an unused part of the binary and then loads that into an unused section of the PlayStation 2 BIOS. Let's draw a picture of this because this is a fun diagram, okay? I really like this diagram. So if this is our PlayStation 2, let's draw a PlayStation 2, okay? So it's something like this, right? It's got like a bit to the side, I guess. And the PlayStation 2 has memory. So we're going to have the memory. It's a big old array. There's a lot of stuff in PlayStation 2 memory. Okay? But basically, there's a region at the start of memory that is for the BIOS. And then our program is going to get loaded in, somewhere down here. This is where the game bin gets loaded. Now it turns out that there's a section of this BIOS that is just empty, completely unused. So we use the PlayStation 2's elf loader. That's the binary format of the files. So we have the elf. The elf has a bunch of sections. It has a code section. We basically add a new header that tells it, hey, take a section from in here and map it into this when you load the binary. So this is cool because it hijacks the PlayStation 2's loading mechanism, and you package this all together into an ISO that the PlayStation 2 understands how to load. Awesome. Bobbius, welcome. PinguiXor, welcome. You're liking this topic, cool. I would love to talk more about how I did this. I'm going to do it in a YouTube video because it was the most tedious shit I've ever done. I did it a couple of months ago, actually, and I've just been meaning to talk about it more. But we're gonna do the code injection part, so we're gonna see if we can mess around with some stuff. I've got some addresses that we can poke, which is gonna be fun. Do I have some addresses? That's a good point. Do I have some addresses that I could look at? Yes, I do. Okay, that's good. I should have checked that before I hit live, but we've got some stuff we can mess around with. So, yeah, this whole thing is a really fun process, and the way it shakes out into command line tools is cool. Also, someone wrote a cutscene skip patch, but they wrote a binary you have to load. So you go into OPL or whatever, you launch Elf, I guess. You run their preloader, which loads the Kingdom Hearts Elf, and then applies a binary patch over it. I wrote some tools that basically hacks that patch into the binary so that and some of it isn't actually loaded in as part of the binary. Some of it's loaded into this BIOS section. So I basically hacked their patch so that I could just package it into an ISO. Haven't published that or told them I've done that yet, so this is a bit of a whip, but this means you get cutscene skip in the game as well, which saves you about a couple of hours when you play it. The game has a lot of cutscenes. It's a JRPG. Cool. So that's fun. So the first thing we need to do is work out how we can write C code that is that not only doesn't care where it's loaded, actually kind of the opposite. C code that expects to be loaded at an exact address. And I think we can do that. I don't think we need a linker file. I think we can just use some linker commands. So there's going to be a little bit of, you don't need to see my Spotify. There's going to be a little bit of Google foo to get this working, but let's make a directory and let's call it patch C. for C patches. I've already kind of played around with this. For example, this is a 60 FPS patch written in assembly that you can load in using that tool. Every frame it sets a special magic address to 0, and that makes the game run at 60 FPS, which is cool. So I've got all these little things I've been writing, but I want to try and write them in C. I actually have a randomizer that works, but it's applied to the ISO, and so every time you want a new seed, you have to rerun all the tooling. It's pretty slow and tedious. So let's start by writing a file called rando.c. We'll have some function. We'll call it void. Now we're going to need some kind of like entry function, I guess, right? Some kind of function that will live at a known address. So let's call it hook. Okay? So we'll have a hook function, and we'll have a... I guess we'll just put it in here. Let's say... Okay, well let's actually do some stuff. So we're gonna have a const int. Consts are actually gonna be tricky, aren't they? Maybe? We'll see. We'll see how we go. Basically everything that goes in here, right? We just need to be careful if we have a data section, if we reference anything. But a constant should get inlined. And this int we're gonna call chest table. Sorry, I've still got mice, so I might be looking around. This is an important question, Bobius. Bobius with a very important question. How much space do we have to work with? It's not a lot. It's not a lot of space. I think we have, so the game gets loaded at 100000, I think. 1, 2, 3, 4. I think. So I think we have F0000. I think we have this many bytes, which is I think we have 65 kilobytes, which isn't much, but also is a lot in the scheme of a 32 megabyte RAM system. So anyway, we got to work that out. We'll work that out as we go. Please Twitch show me my feed. Okay, so we're gonna have a chest table offset, and we're just gonna set this to 0x0 for now because I can't remember what the number is. And each element in this table, we're gonna it basically has two parts, right? And I have some code already that unpacks it. So it's in chest table entry. So it has a type and it has a value and it has a type and an arg. So these are basically the things we want to replicate. And let's do it with a define so that we do it all in line. Super Cricket. I'm rocking the jacket. Yeah. The denim jackets are in. This, I mean, when I moved to Melbourne, I had to get a puffer jacket, but I've gone back. I've gone back to the denim jacket. I can hear the mouse in my kitchen. It's a sad time. So let's do it like this. Let's say we're gonna have a macro offset. It's gonna take an offset. We're gonna get chest table offset. Offset. We'll dereference it sensibly, and the value according to what I was doing before, or the type. Sorry, let's do type. So within this table, the type of the chest it's the lower 4 bits. And the type of the chest is like kind of like the thing that the chest does, and the arg is the thing in it. So for example, I think I have a nice stringer. Where is it? Pars. Yeah, string. Yeah, if it's a 0, then it gives you an item. If it's a 2, it gives you a gummy item. If it's 4, it's dogs. If it's E, it reads from a secondary table of rewards, which is cool. That might not be the correct number. I might have done my math wrong then. I'll need to double check. Again, I had a couple of things I was meant to do before I started this stream, but it was getting to like 10 PM, and so I thought I'd better just start and we'll work it out. So we'll have type, we'll call this arg. And this is the same thing, just right bit shifted by 4. Excellent. And actually, we should probably say that this is... oh my god. Hold on. Excuse me one moment. I think I have caught a mouse in a trap. Man, turns out my neighbors are just doing construction work at 10 p.m. Love it. Wonderful. It's a good day. They can probably hear me say that. Okay, so this is actually an int array. That's the other important thing. And actually, it's not int. It's uint16. Uint16t array. So we need to include stdint.h. Very important header. So yeah, so unsigned 16-bit ints. And so what we can do... the other thing about this is we don't really have a way to set. So maybe we need to say define chest set. We'll have an offset, we'll have a type, and we'll have an arg. And actually, are these 8-bit or 16-bit? It's right shift 4. They are uint16s, aren't they? Chest entry. Yeah, uint16. Chest entry, uint16. Yes, good. Okay, good. So we're just going to build up some nice little utilities for doing this. Chest table offset equals. We don't need this many parentheses. I'm a little overkill on parentheses right now. Offset equals, it is the type. Yeah, the type and type. If I can find the right button. So the lower 4 bits of type, and the arg left shifted by 4. Beautiful. Okay, that's good. So we've got everything we need to manipulate these things. Now, the other magic constant that I've already worked out in the past are the number of entries, which should be 479. Not 480, not 478, 479. So we'll have this. We'll have what is this? I guess it's a size t, chest table size, and it's 479. If I can work out how to type, 479. So let's try this. Let's say for size t I equals 0, I less than chest table size I plus plus, and we'll say chest set I will give an item, and we'll give, let's see if I can remember a fun item, let's say 53, just to see if this works. So we're gonna try and say every frame of the game, so this hook runs every frame we're gonna set every chest in the game to grant us an item from some point. And this should be able to just be compiled. We should be able to do it. So for example, right? I'm going to go into the directory here just to demonstrate. I can say gcc rando.c. Okay, so we also need, oops, I have too many things open in the foreground. We need stddef as well, apparently, for size t. Okay, we don't have gcc. That's okay. Chest set. Assignment of read. Read only location. That's a bit odd. I don't know why that's a read only location. That feels a bit weird to me. Is it because it's a null pointer? That is one interesting thing. Okay, so oops. I believe 103.51530. I think, I don't know if this is right. Yeah, no, sorry. I'm just looking at my notes off screen for where these memory addresses are. This should be right. So this should be the offset. It should be hex 9df3aa. That should be where the chests start. And we're going to work out pretty quickly if we're writing into garbage memory, I would hope. So let me try compiling again. Oh. Yep. Okay, so we need to cast this. We need to say void. Read-only location. Oh, because that's a const. Hold on, hold on. A pointer to a U16 that is const. Wait. How do I read these? How do I read pointers? So I thought this said that the pointer... A const... So there's a few different ways you can express this, right? A pointer that is const to a U16 that is... You read them right to left, right? Pointer const. So if I do this, for example, and say it's static, for example. Nice. Okay, that works. That works. I can even get rid of static. That's fine. But what does it say? So the error says that there's no main defined, right? And that makes sense. There's no main function here. We're using this function hook as our entry point. So we can compile it and we can say, hey, -c. We can say, hey, don't build a full thing. Don't expect there to be a main. And we can even do one better. And I think, is it no STD? No. There's a, hold on, I'm mixing up my Rust flag. So GCC, no STD lib. And that only has one dash apparently. Okay, cool. So we're telling it, hey, there's no standard library here. We're not using any glibc. If we want to use any functions like that, we're going to have to hook them out of PlayStation 2 memory. We're going to have to work out where they live. And I'd rather not do that. I'd rather not use any of those utilities if I can avoid it. Maybe finding the address of printf, for example, would be cool. Memcopy might be useful. I did actually find memcopy. I started reverse engineering this a bit in Ghidra, but I realized I didn't know what I was doing. Cool, so what do we get when we look at this? Well, for one thing, right? If we look at rando.o, right? This is a 64-bit elf, relocatable, x86-64. So with these, I'm just using normal GCC to demonstrate here, but actually, if we want to build this sensibly, we're going to have to use MIPS64, the PlayStation 2 GCC, right? The GCC that builds code for the PlayStation 2. We're going to use the same flags. Okay, now let's see what we get. Let's file rando.o. Cool, so now we have a 32-bit relocatable MIPS3 non-stripped elf. So what does readelf say about rando.o? And I think readelf-a. Yeah, cool. So we can look at what's in here, right? And it's got a lot of stuff. It's got a lot of random stuff. The text area is what we care about, right? We have 70 bytes of instructions, I guess. Data. Now there's something in data which may not be good. We can't really reference this. BSS, NAVI, so all this kind of debugging stuff, comment attributes, great. Relatext. Yeah, okay. So this isn't good, right? We don't want this. This is the kind of thing that is not going to work if we want to load this stupidly into PlayStation 2 memory. These are the kinds of things that will give us problems. So let's see if we can deal with that. So GCC no rela sections. .rel. There is a way to PIC. PIE? PIC. Position independent code. That means that it's going to load anywhere. And we kind of want the opposite. Right? We want position specific code. We want code that's going to load at an exact address and run there. Okay, so let's try GCC linker function offset. I kinda want a freestanding binary, right? A binary that doesn't depend on anything else. A binary that's for an embedded system. Oh, here's the other fun thing to do, by the way. Here's the other fun thing. What's the tool? Is it readelf again? It isn't readelf. It's dump-elf? Dump... No. Bin dump? Bin... What's it called? What's the one called that lets you actually... Is it readelf again? Readelf-D? Rando.o? No. Nips. 64EL. Address to line. GC. Obj dump. That's the one. -d rando.o. So these are the actual instructions we just compiled. So that's cool to see. That's cool to kind of verify. And we can see that these addresses are kind of referencing something. Hook plus this. So they're all relative to hook. Are they relative branches? That would be cool. That'd be really cool. Now, we do have this return at the end, which is going to be a problem. That's going to be a really big problem. Because we're not really returning from anything, right? I guess maybe... We need, like... We need something other than a return. We need a jump back. Okay, but that's okay. I mean, maybe we can do a fake function call. It's just kind of hard because we don't really have room to set up a function call when we jump to this code. So this is a problem I hadn't really thought about, but we'll deal with that. Hook plus 18, hook plus 40. So I think these are relative, right? I think this is okay. I think we would be able to dump this into memory. Just into a random spot and jump to it. The only thing I don't know is where we do the actual loading, right? Where do we dereference our array, our wonderful array that should hopefully be some kind of constant, right? So where is this? Where is this offset? Where does this live? And here's the other fun thing. What if... For one thing, let's say this is a UN16T because that feels more appropriate. So what does objdump say? We're shifting left, add AU, load immediate, load word, S8. What do we put in S8? This, V0. What do we put in V0? 0. Did I recompile? I did. So where does V0? Load it into 0. And down here we jump to hook plus 18, which is here, which is before or just after we set the... Maybe it does actually start here, because what happens? We load V0 into V1, we load S8 into V0, and S8 is the top of the stack. Okay, that's fun. We shift V0 left, we add S8, what the hell? That's weird. Okay, we load this magic number. Now, what is 1328 into V1? SH. Store half word? V1? No. What? Oh, I'm guessing 1328 83. That's too big. Where does 1328 come from? Oh, hold on. 1328. 530. So that's hex 53 left shifted by 4. Okay, that's good. That's good to know where that number comes from. So that's fine. But how do we get this address? I don't understand how S8's being used here. This register confuses and scares me. The other thing is, I think we need to set the ABI, right? I think the ABI might be wrong here. I don't think it'll matter, but it's worth thinking about. Now we do have an example of this. -32. Does that flag exist here? Let's find out. There's so many flags for GCC. Okay, that's okay. That is okay. Patch C. Ah, I didn't realize we were gonna get these weird numbers. What if I say static? Does that stop it? Does that change what happens? If I do elf, if I do read elf, no pi. Let's try this. What do we get here? See, we still get this rela.pdr, which is weird. Hook +0. Rela.text. What is GCC disable rela.text? But yeah, thank you, Bobius. That's the kind of flag I had been looking at. I'm just not 100% sure. Relocation entries. Relocation. So we don't want this. We really do not want this, because this is, yeah, this is gonna do relocation. So disable rela. No. How do I disable it? Okay, well, let's look at someone with the opposite problem. This is the kind of thing I want to say, right? Emit relocks. Okay. So is there a WL skip relocks? Is there a GCC link options? Type exact static binary. What about this? Oh, hold on. Wait. Is there GCC static? Because they're building a static binary. And that is gonna infer no pi. We still get relocations though. Oh, that's so annoying. So the hard part of this is always working out how this stuff works. Static. No std lib, this is good. Static position independent, this is not what I want. So maybe if I tell it an exact place, right? So options for linking. I want, yeah, what I really want to say is load this at exactly like this, right? Somewhere like this. Indeed, we can double check the exact address that I'm gonna try and load this into. Elf. Can I? Maybe not. Yeah, FF. Oh, FF000. Hold on. Okay, that was too many zeros when I did my example. So it's okay, it's smaller than I said. It's quite a lot smaller than I said. It's actually 4 kilobytes, not 65 kilobytes that we have to work with. That's That's small. That is actually quite small. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. Yeah, 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 yeah. Yeah. So that's very small actually. So we'll see how much code we can fit in there. We're at 70 bytes out of 4,000 and yeah. I figure I'll tell it like OZ and we'll be fine, right? Maybe? I don't know. Um, cool. I really don't know why this is being handled like this. But I guess this has to live somewhere. So maybe if I put this, maybe trying to make this a constant is actually a mistake. Maybe what I need to really do is this addition. Maybe it will behave itself then. Let's try. Let's just try. Let's try and bake this in rather than making it a constant. Let's try worse style. You know, theoretically worse style. And just see, and this is the the left hand side of a dereference on the left hand side of an equals sign dilemma that I've now dealt with in my programming language. Okay, so we'll turn this into a define instead. Define chess table offset, and we'll keep it as a uint16t pointer because that is useful. That will make sure everything stays the right size. So what happens if I build this now? What does that binary look like? Unexpected expression equals, yes, because that is not how you do defines. How much RAM did the PS2 have? 32 megs. 32 megs of RAM. So there's more than 4 kilobytes unused in the BIOS. We're just picking a nice contiguous block. And when you think about that, yeah, that's not insignificant. Did I not save? No? What? Did that build? It did. It did. Read elf a rando.o. Alright, come on. Come on. There's still a relocation. So let's see. Let's see if we can GCC place function at fixed offset. And we also want to set the entry point. Linker flag code offset. FP, no, not this, not this. So let's try WL E hook. What does this say? What does this say? Do we have an entry point? Entry point address 0. Yeah. So, and of course, right? Of course it's 0. What happens if I get rid of the -c now? Like maybe that is part of the problem. It'll be an a.out. No relocation. No relocations in this file. Okay, so the problem was the -c. This is better. This is what we want. Now we're cooking. Now we're cooking. Entry point. Yeah, okay. And this has the default entry point of 10, 10, whatever number this is, right? Plus 18 because some random offset. Cool. Now we need the that makes so much sense. That makes so much sense. So now we need the linker flag for let's say LD flags. What is offset? File alignment. There's a flag for this. There's a flag where you can just say address, I guess. High entropy, blank window, image, entry. If there is no similar entry, then we're going to try to pass entry as a number and use that as the entry address. That's kind of like what we want. Fini, init, that's okay. Just symbols, no check sections, no define common, def sim, relax. Relax. option machine dependent effects. Relax, we don't want. Section start. Now, I think this is it. I think we want to basically define the section. Also, yeah, Colt Zero, hi, welcome. Sorry, I missed you sneaking in there. I got absorbed. So yes. So T text. Because for some reason, I think I need a comma here, right? T text. For some reason, the code lives in a section called text. And section start, section name. Okay, so we're gonna put it at FF000. Now let's look at what the elf says. Entry point, FF000. Perfect, perfect. That code is ready to be loaded at this offset. Loads at F1000. Now let's dump it again. D_a.out. I think my neighbors are watering. I hear a hose running. It's 10:30. I don't know what's going on here. We need to use MIPS64 obj dump. We need to use the obj dump that corresponds to the version of GCC, because otherwise it doesn't know how to dump this out. Cool. So that looks better. That looks better. I think this is good now. We can actually see it loading in the address, which is good. Oh yeah, Cold Zero, how's it going? You're not doing your Treasure Planet thing. You bounced, thinking you want to write to doing something unrelated in Godot. Nice. Machine learning frameworks from scratch. That's cool. That's really cool. Oh yeah, you've been around. You've answered my questions in Discord as well about this stuff. I always forget. Yeah, no, that's cool. That's cool. The Treasure Planet stuff was really interesting. I would love to see some more work, like, you know, just like I would love to play with it, because I love that game. I played it a lot as a kid. But yeah, we can see, like, these are the addresses it expects. So, you know, when it branches to this address, and we can actually look this up and see where this is. That's cool. That looks correct. So now the thing we need is to dump this out into a dumb binary blob that we can blindly copy into our PlayStation 2, into our binary, so that we can trick the PlayStation 2 elf loader into copying it into an unused section of the BIOS, as per this diagram. See here for people that are just connecting. I've already written this part. I've already written the elf hack where I add a section to the elf header. It turns out that there's just enough room between the end of the section headers and the elf segment headers, section headers, segment headers. The section headers are at the end, right? Something like that, something weird like that. The segment headers. There's just enough room to sneak an extra one in if I mulch the first 5 to 10 instructions of the binary, which it turns out are just zeroing registers, which it turns out is redundant. So that's really fun. So we have enough room to just add some arbitrary garbage. So I'm concerned that the only way to actually dump this out, well, so can I get obj dump, right? So obj dump bytes to std out, right? Can I actually just get the bytes of the program? And I think I actually kind of already did this, right? Because I made d patch build it obj dump d. What am I doing here? Oh yeah, that's right. Tail n plus 8. Awk print 2, yeah, this is the actual binary. So we can actually do this, right? So we can say tail n plus 8. This is fun, right? Oops, patch. We can do this, right? So we cut out, so this is a pipeline. This is a really fun pipeline. Because when you do this obj dump, you get a bunch of stuff, okay? You can do it like this. I don't know why there's a discontinuity here. I don't know. Is this truncating the output for me? Is this like trying to protect my delicate little brain from the full force of this output? That's a bit annoying. We can pipe this into awk. Print 2. I think this is how we do it, right? Yeah, now these are the bytes. These are the now we're cooking. Now we're cooking. Here are bytes. This is the binary, right? This is the data from the binary. Now, man obj dump d. Disassemble. disassemble. Just optionally disassemble those sections which are expected to contain instructions. Symbol, arguments given, starts at symbol. No matches, nothing be displayed. Oh, non-empty. No, that's not okay. Obj dump the truncated output. We want the non-truncated version, right? File truncated. No, that's not right. Is that right? Is that just expected? Is this just correct? Why in this obj dump is there a gap? What happened to 4 and 5, 4, and 5, 8? Where did they go? Why is there a dot dot here? What's going on? What's going on here? Is this incomplete? Because here's the branch, right? We branch up. Is this just zeros? Do we just have some padding zeros? That's weird. That's weird, right? What's going on, guys? What are you? If I just ignore this, we're gonna be. If I just like turn this blank line into zeros, we're gonna be a word short, and that's not good. That's really not good because this jumps to 40, and then here we don't jump, and then we maybe just have nops. I don't know. That's strange, right? What's going on here? What do I do about this? Obj dump ellipses in output shortened. There's no ellipses here. Raw contents of an elf section. Obj dump, yeah. Main grep text. Huh. Okay, the size, yep. Yeah. I've written Python scripts that kind of do this, right? This is fun. Because yeah, they this is true. Okay, this is a better point. This is a much better point. Let's use this. Let's a dot out grep text. This is actually pretty great. This is pretty great. So this is the size. That's the address. This is the offset within the file. Cool. Okay, but I'm going to write a script to do this. So let's go mips 64. Actually, can I obj dump? I should be able to obj dump without the mips 64 version. Yeah, cool. I don't. It's only when I disassemble that I need to use the specific PS2 SDK version of obj dump. Otherwise, I can just do this the sensible way. So let's go obj. Let's say size equals obj dump target h target grep text. We pipe that into awk, and then we print. What do we print? Is this column? Whoops. Column 0, 1, 2, 1, 2, 3. I think it's 3. I think I want 3. But this needs to be in single quotes. And then let's do the offset, and this is 1, 2, 3, 4, 5, 6. Okay, that's probably because my print was a dud, because that's in single quotes, so I didn't need to do that. That looks good. Those are the correct things. There we go. Yeah, thank you, Bobius. That DD actually makes a lot of sense for this. I was going to write a Python script to do it maybe, but I like this more. DD is a very scary command, though. That's got to be said. DD. Okay, so count equals size, skip equals offset. Sure, that sounds good. That sounds good. BS is 1, so we're doing it per bytes. Input file equals target, out file equals... Actually, let's do it like this. Let's say... so we really want to make sure that 1 exists. Is it set E? So we're going to do it for a.out, and we're going to say foo is our output. Okay, now. This is interpreted as a base 8 number. That's fun. That's very fun. Let's do it like this. This way you don't get any base 8 nonsense. So we know they're hex numbers. Let's do it this way. Oh, 0 multiplier. Hold on. Okay, can I do it like this? This is the real test. There we go. 112 bytes copied. Cool, and then if we look back at this obj dump, the one that has this, so we want EOFFBD27, EOFFBD27. Cool, so these are the bytes. Beautiful. Thank you, Bobius. That is a very, very cool little script. Nice. Rare appropriate use of DD, right? We're chunking the middle out of a file. This is the right tool for the job. There's maybe other tools that would also do the job. Like you could also head and tail it, I guess. But this is almost certainly the right tool for the job. It's probably going to be a lot faster. Cool. So we can build a file. We can dump everything out of it, which is delightful. Very, very delightful. What next? Now we just need to dump it into the actual binary, right? That sounds good. So yeah, I mean, like, what happens? Can we dump foo into our game binary? We almost. We have most of the tools to do it. The only thing that I need to consider is what order we do this in, right? The order is important. The order is important. Oh, and also, actually, no, hold on. This won't work. This won't work yet. But this won't work because if we look at the disassembly, it ends with this return, right? It jumps back to the return address. And that's really, really not what we want. Not right... I mean, not right now. We don't, in general, want this to happen. So how do we avoid it? How do we avoid it? Well... How do we avoid it? That's a great question. Let's do something else quickly first, just while I think of it. Foo is 112 bytes. It's hard to get something much smaller than that, but also, like, you know, there's no scaffolding, there's no support. But in our GCC command, wherever this went, and I should put this in a make file before I lose it, because these flags are good. Obj dump, blah, 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 blah. This. There's another flag that we can use here. We can say OS, or OZ even, optimize for size at the expense of speed. Let's just see what happens if I re-extract this. That is now 40 bytes instead. So that's actually significantly smaller. When we only have 4 kilobytes to work with, that's a third of the size, right? That's insane. How is it that small? Let's have a quick look. Let's have a look at the obj dump. How is this code being called anyway? We jump to an arbitrary address from... So I overwrite... I have a trampoline. Trampoline, I don't know if that's the completely correct term, but basically there is a series of 3 function calls in a row in the main loop of the Kingdom Hearts game. The first one of those I have replaced with a call into my code that returns back to the next function call, right? It jumps back into the chain of function calls once it's done. So it's very primitive, but very effective. Very, very effective. When I was writing these patches in assembly, it was really easy. But now there's actually a return. I do wonder what happens if I say the function is no return. Like, does it still emit a JR instruction, or does it just not? Because if it doesn't, that would actually be fine. The idea is that you could load a couple of patches in a row. Okay, let me look at what gets emitted here. So, first things first, let's look at this obj dump. We still have a JR. What the hell? What the hell is this? Load or add branch. Holy crap. This is optimized. This is how is it doing all of that stuff in this little code? I can't make sense of this. We load this, we store, we add to, and then we loop. We loop back to here. What the hell? This is a tight loop. That's freaking ridiculous. Surely this doesn't work. Surely. I guess because it writes the same value every time. Oh, I see what's happening. It's loading the lower 4 bits and then the rest of the 16 bits once. Then in a very tight loop, just setting that, because it's setting the same thing every time it's able to do that. So if I set different values, that loop gets bigger again. But that is an insanely good optimization. That is tight. That is tight. Congratulations, GCC. That's very, yeah. Once you think about how trivial the code is, like that's how a human would actually write it, right? But it's still pretty cool. So what happens, so GCC no return. We're getting into the real weird edges of GCC here. No return. What does no return do? Let's try it. Let's try it. That's not what I want. Hook. I think it goes after, right? It goes. Do we have to declare it ahead? Let's try this. Attribute no return. Does this need 2 parentheses? It does. It needs double parentheses for some reason. Thanks C extensions. Okay, so we need to forward declare this. Hook. Like this. Warning, no return function does return. Yeah. Because if we look at this code, like just because of C semantics, the end of a function is still a return or not. Let's do this. This is exactly what I want. This doesn't have a return. So oh, that's a really cool use of the slot as well. The way MIPS instructions work, the same as RISC-V. After a branch, there's a delay slot. So every time this branch instruction is hit, this delay slot's also executed, because the way code works, right? The way it like fetches code, it's always going to fetch the thing after the branch instruction, whether the branch is taken or not, just by the nature of how these things tend to be optimized. So we always look at the next instruction and execute it, even if we branch back up. So this is a block of code that's going to do what I want it to. It wants to load at a certain address, but other than that, it can just be dropped in. MIPS assembly is quite readable. PPC is as well. What's the meaning of LUI versus LI? LI isn't a real MIPS instruction. I don't think. LI is shorthand for something else, I think. Maybe, but LUI is load unsigned immediate. I think, let me check the actual specs, the actual PS2 specs. Let's look at the EE core. Well, I can't search for LI, unfortunately. Where are we? CPU instruction set. LH, yeah, there's no LI. LI is shorthand for something else. But, oh no, sorry, unsigned. LI, yeah. LUI is load upper immediate, which is the upper half of a word. The lower half of a word, I guess, is controlled by like an add, right? Where you add, it's like an add immediate. So basically it's one of these instructions. And if we look, you'll find that this li is actually an add. It'll be add v0, add this immediate to 0 and store it in v1, right? That tends to be how these things work. Or add it, or rather add it to, well, yeah, 0 is fine here. This is the little n, so 0, 0, 0. I don't know, it's not this instruction, but basically it's something like that, right? It's li isn't a real instruction. It could also be like a variant of or something. But yeah, lui, sorry, I always say unsigned because that's where my brain goes, but it's the upper part of the word. All right, so we have some data. Dinkelman, welcome. Welcome, come on in. We are about to try and run some code on a PlayStation 2, I hope. Let's find out. Let's find out. I need to quickly, we've got the blob, so that's good. We've got the blob. I need to quickly review my patch loader, which is written in Go. And the way this works, God, this works in many ways. It does a lot of things. Do I bring a fire extinguisher? Man, probably. Some things might be about to burn down. It's just my computer. That's okay. So we move the section headers around. This does a lot of really fun stuff. I want to make a YouTube video and talk about this process because it was so insane. It's literally one of the most insane things I have ever built, but it was really fun too. So injected code start. Where do we get free memory address, injected segment offset? Free memory address. So where is free memory address? Free memory address is a constant. Well, it's not a constant. It has a constant. I didn't build it on stream. I know, this was honestly too hard to build on stream. I couldn't do it on stream. I couldn't do it on stream because I didn't know if it was actually possible, I guess. That's the important thing. Injected code start address. Okay, so this is the important part. The hard thing about doing something on stream is if it doesn't work, it's just like 10 hours of blue balls, you know? It's more of a YouTubey thing where I build it, and I have footage of me building it. I wrote it all in Python, and then I rewrote it all in Go, and it just like, it's really, really crazy. Okay. Main loop hook address. So that's where in the main loop we actually jump out into my hook, into my code. Injected code segment offset. Hook main loop. Game elf config. Append new headers. Okay, so we want to go into elf, kh patch, new patch from image. This is where we actually like build our patches that we apply, which is cool. Patch from machine code, that is also good. Patch config, move headers, apply new headers, hook main loop. Patch result, injected code segment offset. Res, where does res come from? Res comes from patch elf. Okay, so elf. With a list of patches, that's fine. We try and do, yeah. Okay, so here's what we're gonna do. We're gonna not have cutscene skip. I think that's basically the fact that I want to try and load two things at once is gonna be the problem here. So let's go into bin patch dot bash. We have a little, where did I put this? Patch equals nothing. Patch equals patch c foo. Okay, this is our patch, and we're gonna get rid of this for now. As annoying as not having cutscene skip is, we're gonna get rid of this for now. And let's bash, we'll get rid of this folder and then bash bin patch and see what happens. So that looks like it succeeded, which is good. Injected code here, which is where our code expects to live. That's wonderful. Let's do it. Let's run the game. PCSX2 QT temp WP Kingdom Hearts ISO. Let's do it. Let's do it. And let's hope I don't get copyright striked for having music from a game in my stream. I imagine that's only the... Oh, hold on. Did something bad happen already? Okay, it looks like we already crashed, so that's nice. That's good. Why did we crash? What went wrong? What went wrong? Let's open our debug. Let's restart and open our debugger. I mean, something's happening. We're looping. some loop is looping. Let's break. Let's put a breakpoint in at here when we execute this. Okay, there we go. So we're looping forever. And we have this RA. Where did this come from? That wasn't in our thing, right? We didn't have any RAs. You've been researching garbage collection, you're building a Lisp. Nice. That's cool. Yeah, I love the idea. What I really want to do one day is build a Lisp on stream. This is fun garbage. I want to build a Lisp on stream, and then I want to, like, I don't, maybe a compiled Lisp would be fun, right? When I need a new compiler project, but have it not have a garbage collector. Just have it, you know, have a really dumb allocator that never frees anything, and then at some point it just runs out of memory and dies. Even an interpreted Lisp, right? But then write... well, I guess it has to be compiled in this case. Then use that Lisp to write itself, but with an actual garbage collector, but only ever write the garbage collector in Lisp. I think that would be a fun project. I could get behind that. So what happens at the end? This is riveting. This doesn't look like what we tried to load, right? Because wasn't there this really tight loop, right? Or add, shift left. Wasn't there an add here? Wasn't there something after the branch slot? Also, wasn't it a B? Was it a B and E? This looks different to what we had, right? So, branch if V0 and V1 aren't equal. So they're getting closer. Let's put a breakpoint here. Let's do it when this loop exits. So what happens when we return? Where do we return to? Where do we return to? What the hell? And then we jump back here. Okay. Okay. I think I know what happened. I think I know what happened. Yeah, so this is where we hook, right? But for some reason we're jumping back to the wrong place after the hook. And that's probably because we're supposed to hit this. There's not supposed to be a JR here. Okay? So what's going on? What? Oh, wait. Wait, did I just not run... Did I just not run this again? Did I just forget to run this? 24 bytes. Is that... Let's try again. Let's try again. Let me just make sure I actually did the thing I was supposed to do. And then we'll see if we can run this without it just crashing. That's promising. Okay, that's good. That's actually good. I know it doesn't look good, having a bunch of TLB misses, but that is actually good. So what we're going to do, we're going to put a breakpoint again at the address of our thing, FF000, when we execute there, and we're going to reset the console. Cool. So any second, this is going to stop. Nice. Let's see what mysterious error has occurred to cause us to TLB miss so drastically. But yeah, now you can see the branch and the add. The add comes after the branch, and then we jump and link to something else, right? So we don't actually jump. We don't actually return from this, which is cool. And then we jump back. We don't return anything. We didn't call a function. We just took a sudden left turn to somewhere else that the system didn't expect. Also, you can see there's a bit of free space above here in the BIOS too, by the way. There is actually more than 4 kilobytes I could use if I'm desperate, but I just need to work it out and make sure. it seems like the li is indeed an add immediate unsigned. This is the classic MIPS experience, right? The li mnemonic is useful, but yeah, like anytime you're loading an immediate, you're really just adding an immediate to 0 and storing that in a register. Okay, so this is a really tight loop. I like this. And then I can just like click a lot. Now, hold on. I think I see a problem here. Does this instruction look... I know it's very small on the stream. I had to get kind of close to my screen just to be sure, but can anyone see what this instruction is? Does this say branch if equal 0, 0? Does this say branch if 0 is equal to 0? Why is anything ever happening? Why aren't we Well, of course this gives us a TLB miss. What the hell? Because we're just going to keep counting forever, and at a certain point this is no longer going to be valid memory. So I can put a breakpoint here, right? We're never going to hit it. We're going to get a million TLB misses because we just what? That's freaking ridiculous. Okay, so let's obj dump this again. If I can, let's look at what's going on, okay? Because this B is obviously not what it thinks it's compiling. Well, yeah, it is. Actually, this is exactly what it thinks it's compiling, because it's saying B is also an instruction that I think doesn't exist, if memory serves. Let's remind ourselves. Yeah, so there's no B. B is mnemonic. All B means is branch always, which is no doubt compiling down to branch if equal to 0, 0. Let's have a look. Offset RSRT, and they should just be zeros, right? And that's a lot of zeros. So that looks like this is branch if 0 is equal to 0. No freaking wonder. Okay, so here's what we got to do. We're going to recompile this. I need to put this somewhere. We're going to try compiling it with O. We're going to try compiling it with OS. And I love this warning. I love this warning so much. Okay, so obj dump. Work your magic. What do we get here? This is still branching forever. Okay, that's fun. Is this a PS2 SDK bug? Is this a PS2 dev bug? What's because there's this other thing, right? There's this, but that's okay. Here's a thing. PS2 SDK. Let's look at their makefiles. Let's just double check their sample makefiles. EE global sample, right? What do we have? No default libs. Start group. Link some stuff in. Options. O2. Or optimization flags. O2. C compiler flags. I don't know what G0 is. Mon flags, linker flags, assembler flags. That's for AS. Link file. Okay, there's nothing too crazy here, right? Other than, you know, it sets up the stuff. We strip some things out. Okay. Cool. So there's no weird like N32 ABI or something we have to do here. This is really just seemingly a compiler bug. So this would be interesting to report to someone, right? Let's look at how big this is now. But this is still a branch forever. Why is this a branch? Why is this a forever loop? What's going on? What have I written my code poorly? Right? This is the other thing, right? Have I just made a typo that is making something factor out? You can never rule out that my code just fucking sucks. But this looks good. This looks like real code, right? This looks G0 is no debug info. I mean, I can probably do that, right? Because we're never debugging this code. It'll just be smaller. Let's get rid of the optimization flag. G0. Okay, well that's better. Let's try this. It's a lot bigger. It's like several orders of magnitude bigger. But let's try this. Bash extract. We're going to extract from a.out and we're going to put it into foo. Then we're going to run bin patch.bash. We're pulling out we do have the space for this. And like I said, once my loop becomes less trivial, that optimization will be less important. It would just be nice to know. Wait. Okay, well there's another thought in my brain that I might have to fix, but the thought, not my brain. My brain doesn't need fixing. It's 11 p.m. and I'm staring at a crashed a crash for a 22-year-old game, but it's only 21 years old, right? Actually, brain doing brain things. Yeah, I'm pretty sure my brain's okay-ish, despite my life choices. Okay, so there is a thing, bin patch. Let's say fast equals 0. Where are we? We're going to do the copy. We're going to copy a clean ISO in. And then we're going to run. Because if you run this multiple times, it doesn't know that it's already tampered with the elf. And then it'll try and double tamper with the elf. And sometimes that blows up. Now, unfortunately, that's still not the problem. Because it's still not running. The good news is, it's really easy to just put a breakpoint in here and see what happens when we hit our code. And we're hitting our code, so that's good. That's good. So, whoa. This is a lot more code now, which it makes it a little bit harder to work with. Oh. Hold on, I didn't read my my stuff very well, apparently, because if I look at my C patch, if I do my obj dump, Sorry, I'm pressing the up arrow so many times. I know that must be really upsetting. We have a jump return again. Okay, so here's a stupid thought. What if I just drop the last 64 bits off of this file? What if I just subtract 8 from the size? Right? What if I actually even better? What if I just say ls alh. So foo is 112 bytes, right? So I want to drop off the last 2 instructions. Each instruction's 32 bits. So it'd be it'd be 104 bytes without those 2 instructions. So what if I just say tail, is it plus 8 foo? What's this? $105. Okay. Wait, is that how I do it? No, wait, tails from the end. I want the opposite. I want head. Minus, yeah, that's what I want. Okay. Okay, nice. Let's try this. We've hit that point in the night where we're gonna truncate 2 instructions off of my code. Oh, holy shit. We need to fast equals 0 bash bin patch. I have to say fast equals 0. So the fast equals 0 basically says copy the ISO back into the working directory and do this again. Otherwise it doesn't recopy the ISO, and yeah, we end up with this problem. So I don't think I explained that very well before, but that's okay. Do I have a thing? Do I have a thing to run the game? That would be useful. I don't. Okay, this time it's gonna work. This time it's gonna work great. I've got a good feeling about this time. Oh, holy crap. I actually didn't have a good feeling about that time. Oops. What am I? No. Don't do it. Don't do it. What's this UI? Okay, there we go. Crisis averted. Whoa, that's new. Not seen that one before. Oh, oh, that's wonderful. That really really hit me somewhere good. Um, Holy shit. Okay, so what am I doing to this poor? This is one of my favorite games, guys. Um, Bobbius has some good extra facts in chat. I'm gonna look at that in a sec. I have no idea what I just did. I must be corrupting. I don't even know. I must be corrupting like texture data, even corrupting draw commands. Let's reset. At what point does this all go wrong? Where does it all go bad? See, I love you can actually see the moment I hack the elf loader to put something into the BIOS. So, what do we do? This is the instruction that really should be where stuff kicks off. And we hit it. That's the function that we tried to call before. And then this is where we jump back to... That's okay. You can jump to an op. That's fine. So basically what the hook does, like there's a jump and there's a function call here. Instead of calling the function, we take a left... Oh, wait, hold on. I realize there's a fatal problem with this. And that is that I'm not saving and restoring the function state. Basically, because this isn't a... So this makes sense, right? We come through here, it expects to do a function call here, but we actually say, hey, nah, we're just gonna jump to this random place. Jump to follow branch. So then we start executing this code. And this is fine as long as we don't use any registers that are important later on. But I don't know if that's true. I don't know if that actually is the case. I know when I wrote assembly to do this kind of thing, I was very careful. So maybe I should actually just be writing assembly to do this, right? Maybe I randomize a logic in assembly. Corrupting registers seems good. Haven't experienced quite like that. Double Treasure Planet PS1. Funny audio corruption. Audio would just start looping infinitely. It would be really easy to just like change a bit that makes that happen, right? Okay. So what we might try is using temporary registers. Well, okay, no, so hold on. So what we can do, right? What we can do, if we jump to a point that calls a function and then returns, we should set and reset the state appropriately, right? As long as we understand the calling convention. Now, I think PS2 games might actually use a different calling convention than PS2 SDK, so that can be kind of tricky. MIPS 32 N64 ABI. I think it's N32 ABI, right? Oh yeah. Hold on. MIPS MABI equals. What does PS2 use? What does it use? MIPS PlayStation 2. Cold Zero, you're probably the resident expert in this in chat. Is it N32? I think it's N32. I think it's going to be the same as the PSP, right? I know the person doing Sly, injecting code into Sly Cooper and the Thievius Raccoonus had issues with this. This is important. So we're going to go to patch C. Okay, so we're going to do this jank thing, right? First off, Bobbius has also provided more goods. What's this? Unreachable. Whoa. The program is undefined. Useless and cannot deduce. Immediately following ASM statement. Huh. That's kind of cool, actually. It also generates code to return after the ASM. Yeah. Okay, let's try it. The other thing is I could just hard code an actual return address. You haven't done any code injection. That's okay. That's okay. Honestly, it's a lot of work. It's a lot of pain to get code injection working on the PS2. I don't know if it's worthwhile. Don't know if it's worthwhile. It's built-in unreachable. Let's try this. Let's try this. No return. Blah blah blah. Cool. So, what I'm gonna do instead, I'm gonna add a function. I'm gonna say function void. We're gonna call it randomize. We're gonna call it shuffle chests, even though it doesn't actually shuffle chests yet, right? We're gonna put this loop in here. So we're gonna call a function. When we call and return from a function, it's gonna hopefully set up and restore the registers correctly and respect the calling convention. We'll find out. The problem is that the following code, like, it probably knows that it's just built-in unreachable, so it probably won't try and restore anything. We'll find out. We'll find out. Okay, so we're gonna compile. We're gonna compile again. And we're gonna say march equals, oh no, sorry, mabi. ABI equals n, I think it's n32. I'm not sure after the function call. Yeah, I didn't really understand what you were saying there, Bobbies. Implicit declaration. Oh yeah, I can forward declare that function. Void shuffle chests. Cool. Let's obj dump this and see what's in it. It still has a return. It still returns. Beautiful, beautiful. Oh no, this returns. This does not. This does in fact not return. That's good. It pushes things to the stack. Does this return? Okay. Let's try this. This does some stack stuff. The other option is writing my own assembly stack prelude and postlude. ASM jump before unreachable. Well, so ASM jump, I could do this as well, right? But I know, well, it's kind of tricky. It's kind of tricky. Oh, actually, yeah, that's the problem. That's the problem. So the problem is, right, it's hard to show without running the game. So let me re-extract, and it's almost certainly not going to work again. If it works again, it really, truly is a fluke. 136 bytes now, so it's a little bit bigger. It's a little bit bigger. Bin patch.bash. We'll just go back to using the file foo. We will fast equals 0 bash bin patch. The problem is, yeah. I think I get what you mean now. You have some neat ideas. 30 kilobytes of space to write code in. That's really cool. Load and bend assets from disk. Yeah, that would be really, really cool. That'd be really cool. It's definitely hard moving stuff to disk from the binary, but definitely interesting. Okay, so PCSX2QT temp WP kh.iso. Let's see. I'm expecting a similar result. And the reason is that we're mulching a function call, right? But the thing about mulching a function call is we expect, so let's do this, execute ff1000. So if I reset this, we're gonna hit it. We're gonna hit it at some point here. I love seeing that get loaded in. That's very satisfying. So we do some stack manipulation, right? We restore RA and FP before we call this function. But when we eventually follow this through back and we go back to, for one thing, why are we doing this twice? I don't know. That's weird. Follow branch. Okay, so we jump back here, right? So usually this jump and links to a function. We set up v1 and v0 before we jump. But then when we follow this branch, we do some other stuff. So, and you know, we use v0 and v1. So what I could do is write some assembly that stores vu and v1 to the stack and then restores them from the stack before we return, before we jump back. That would work. That would definitely work. Are there any other vu v1, vu v1, v1, vu vu v1, a naught? Let's just try and do v. Well, oh no, but a naught is an arg register as well, right? What's a naught? A naught. I don't know my calling convention. MIPS 32, N32 calling. Let's do 3 registers. Screw it. Let's do a naught, v naught, and v1. That feels sensible. So let's write some assembly. Oh no, and I have just realized what this actually means. This means writing this assembly syntax, which is always disgusting. Is it like this? What's this called? AT&T ASM syntax GCC. I hate it. I hate writing it so much. ASM. Oh yeah, we need to say volatile as well. Is it like this? O32, return values stored in v0 and v1, arguments, past function registers. Yeah, okay. Xlinks, hello, welcome. Yeah, I can see why this kind of thing would be compiled into the game. Like it, you know, it could have been generated in all kinds of strange ways. Never written inline assembly. Yeah, it's easier to read than write. There's just all these little things about the syntax that are really freaking annoying. GCC inline ASM examples. I just want to copy someone, right? Here we go. This is nice. I love these blogs. Thank you, Alex. Okay. Okay. Give me a more... So only one parentheses. I think that's the important thing. We're not going to do this stuff. We're going to ignore this. Let's see. Let's see what happens. So what I want to do is similar to what happens when I look at this. I want to move the stack pointer enough to... Well, here it does at 16. Return address SP. Because I guess these are 64-bit registers, right? Thought I had a huge beard. Oh, because of like this. This is like, yeah. I see that. I also think the flannel shirt and the denim jacket. It's just got like big beard vibes. I definitely got a spiritual big beard in this outfit. So before we do anything, right? Before we do anything here, we want to. I really need this like side by side. Add IU SP. We want to add enough room for 3 registers, which should be 24. And then I think we need a new line, right? Maybe? Wasn't there a bug about this? And then, so yeah, they're strings, which is kind of weird, which is kind of really weird. So SP. Oh yeah, -16. Sorry, that's the other thing. Stack grows down. Then we store a double word. We just have to remember the order, right? So we store v0 at the top of the stack. We store v1 at the next element of the stack. Wait, hold on, and that's backwards. Is that backwards? Is it? Yeah. 0 SP. This is such an ass backwards way of writing assembly. SP. And we want to store A0. And then I think I need to put like colon down here. We'll find out. The compiler's going to probably yell at us here. Okay. GCC is going to be very upset with what we're trying to do. Yeah, it's like, what is this? I think that's because I don't have new lines. And this is really, really silly, right? But you need these new lines. Okay, invalid operands. What does that mean? What does that mean? Now, here's a funny thing that we can do, okay? Work PlayStation 2, PS2 SDK, math. We can actually find just someone's example of this and kind of copy it, which is nice. which is really nice. So, oh, that's right. I think the register names need something else. They need a $. It's really weird. I don't know why it's like this. Was it Phobes that found a bug with some assembly stuff that was behaving really weirdly, and it was just the missing new line, or was that someone else? I remember reading that. I thought I read that on Hacker News, but maybe not. SD. Invalid operands. Oh yeah, because this needs a $. Okay, that actually worked somehow. Let's obj dump it and see if my code showed up. And it did. Except it appeared after this thing for some reason. Why are we... I mean, that's okay. Like, it doesn't matter what order that happens in, I guess. Why do we push... Yeah, Kingdom Hearts Final Mix. The chess table actually lives, like all of the chests in the game, they're hard-coded into the binary. So I've got a tool that extracts it into either a blob or a JSON file so you can poke around with it, or like a human-readable file. And then you can repack it into the binary, which you then have to repack into the ISO. So it's like this weird multi-step process that's really fiddly and easy to do wrong. God, I swear I can hear mice. It's weird. Once you've had mice for a little while, you get more like paranoid. You're like, you hear them everywhere. You think you've got a mouse in the shell. Okay, so I'm gonna try doing it like this, right? I'm gonna try storing and returning them. But yeah, the other thing is I can definitely put more inline assembly that does the stuff that the binary patcher currently does, but I kind of like the idea of it being in the patcher so that you don't need to know or care about it. So then this is the opposite, right? We add... So we get back here, the stack pointer is... I don't know where the stack pointer is. Actually, no, I should wrap this in a function because then I know that the stack pointer is where I left it, right? When I call this function, the stack pointer is gonna be stored. So what do I do here? I want to load a double. I want to load v0 from the start of the stack. And I want to do the same with v1 and a0 from 8 and 16. And then I want to add IU SP 24. I want to add 24 back to the stack, and then when I jump in, we've restored everything. I hope. I really, really hope. Oh no, hold on. I didn't undo enough. Where did my wonderful function go? There it is. That's silly. Okay, so when I build this now, it's certainly gonna work. Which is weird. I feel like it shouldn't, but that's okay. So this code now this no longer works because it expects to just fall through. Okay. That's a problem. See, this function has to actually do something at the end. So what I could do, and I'm getting a bit desperate to just see something work, because I like to see some results in a stream, right? I like to see something happen. So let's go patch go. And let's see if... No, hold on, that's not the right file, is it? Patch go. Yeah, this one. So main loop hook address. I want to find the address that we set at the back. Where do we go back to? How do we work out where to go back to? Apply new headers, that's fine. New patch from image, that's not what I want either. Move section append, hook main loop. This is the one. Is it? No. Yeah, hook return. This is it. Jump back to game. Instruction. Hook address. Right word slice. I actually, have this weird, I actually like make the instructions in a Golang binary, which is cool. That's really fun. Jump to hook. Yeah, so I actually build the instructions in line, which is interesting. Jump to hook instruction. MIPS jump here. Injected code start. Jump to hook. Yes. Replaced instructions. Blah blah blah. Oh, see, this is all. There's logic here that's a little bit scary to deal with. Jump back to game instruction. Target hook address plus 4. Okay, so we could do that. We could, but we need to call the function we replace. So this is the kind of thing. The magic here is that it can look it up and work out where to go. So what I need, it just is layers of weird hacks. That's where I am right now. That's the hard thing right now. What I need is the ability to jump somewhere. I don't think I can fix this tonight. Just for the sake of something fun, let me show you what actually does work. Just so I can show something this stream. This is the state of the... I might have shown this on stream before, actually. I can't remember. PCSX2 QT. I've played this most of the way through, which is cool. I hope this works. Yeah. So this is patching the game by unpacking all the files and then repacking. And so you can load it up, you can run around. I've got a couple of testing save files at various points in the game, all fairly early. And let's go open a chest and see if the contents are randomized. This is just before the end of Travis Town. I don't think... Does this have 60 FPS on? I don't... Oh, it might. You can always tell. So yeah, it turns out that 60 FPS you can just enable and it runs really well on emulator. On physical console, it drops quite a few frames, but that's, you can kind of deal with it if you want. It makes some jumps really hard. Cool. But yeah, so it's Kingdom Hearts. This doesn't have randomized rewards from like bosses and stuff on, because when that happens, you one-shot every enemy because it messes up your strength for some reason. So you open this chest and you get dogs, which is not what you get in the base game. So that's fun. That's fun. So the randomizer does stuff. Very annoying to do good air combos in this version of the game, just because of the PS2. Cool. But yeah, things like enemy drops would be fun to work out how to randomize as well, but there's a lot of memory addresses there to find that I don't quite know yet. Nice. That is always fun. So you definitely don't usually get that here. So yeah, it's definitely a lot of fun. It's fun to goof around with, right? Yeah, so it's cool. So I know that this works in theory, and it's just finding the right combination of things. Maybe I do just need to write a randomizer in assembly, and I don't think that's too bad to do. I think that's actually surprisingly approachable. It's just the logic of, like, I don't know, the more logic I want to add to it, the more annoying that will be. But assembly isn't scary, right? Assembly's fine. The other thing is, maybe I can write some of it in C and just have a call into it from assembly. But then I need to be able to order things correctly. So that's another thing to consider. So that's fun. That's fun. It works. But yeah, like guaranteed ordering of things. Like, can I... And I think that linker scripts can do that, actually. GCC linker script. Okay, well that's not good. There is no way to do this. Unless... Okay, so there are ways to do this maybe. Each function in its own section. Okay. So there is some awful hack that I could do here to mix in either assembly, or I could have basically what I'm thinking is maybe like, oops. If you have your, so this function wouldn't be a no return anymore. It would actually return a hook. But instead of this, you would say, let's say void. Let's use this kind of terminology. Attribute no return. And then we'd say, you know, void fini built-in unreachable. So we'd have this function and guarantee that it was at the end, right? That it was the last thing in our binary. And then once we were done, we could just jump to the thing at the end, right? We just call that function. We jump here, but then there's nothing, so we just fall through into whatever comes next. That's the dream. That's the dream. So that would be nice to be able to do. It's just, I don't know if it's really possible. So this feels like a decent skeleton. I just need to know if this bit's possible. That is the goal. And the thing I just read said it isn't possible. So maybe I need to do some weird compiler magic. Maybe I need to play with that more. But this is why I'm always scared of approaching this stuff on stream, because sometimes you just spend a bunch of time on it and you get nothing. On the VM front, I have been rewriting the assembler to emit things in a format that means I can intertwine the assembler and the language. So that would be fun. That's what I really want. I want you to be able to write a bit of code and a bit of assembly and glue them together, and I have made life very hard for myself by wanting to support that. But it's going to be good once I get the website up and running a bit more, which is also coming along. Yeah, awesome. Assembly isn't scary, verbose, and not good for anyone with bad working memory. That is an interesting assessment, and probably quite a good assessment. Maybe it would be fun. Maybe I should just write a full logic randomizer in assembly. Maybe that would be cool. Maybe that'd actually be interesting. If anyone watching this knows memory addresses in Kingdom Hearts Final Mix, if they know where, like, you know, memory addresses for magic rewards are, that would be cool, because I don't know. And things like enemy drop tables, that would be fun to play with. I don't know where they are. If I could randomize them, that would be cool. I'm gonna make it happen, and my tools aren't open source yet. They will be at some point, like my Go patches, the things that I have pieced together. So this is my randomizer bash script that uses my command line tools to unpack and repack files and shuffle. I've got a Python script that shuffles rewards. Yeah, it's cool. And you can actually see WP. These are all the rewards in the game, all their offsets in the table, what they are, which is fun. Some of them, I haven't named the items yet. I think 50 anything is like a Sora item. But yeah, it's cool. It's cool. It's all there. The tooling's coming together slowly. Never got into Kingdom Hearts, found the Disney stuff off-putting. I got Kingdom Hearts for my 7th birthday, and it was like the best thing ever. But I think getting into it as an adult would be kind of rough. The first game holds up really well. The first game is a gem, but the series has gone in interesting directions. I've played pretty much all of them and enjoyed most of them, but it's... Oh yeah, the first game is very frustrating, right? It's one of those things where it's really fun to play because I know where everything is, but there's a few parts in the game where it just gives you, like, it just throws you into the deep end. It's like, you've got to do this very specific sequence of things, but we're not going to tell you what they are. We're going to let you work that out. That's an exercise to the reader. So that's fun. Anyway, I'm just rambling now. Let's finish it up. Let's find a fun channel to raid, someone doing some cool coding. I'm always happy to take suggestions for a raid, because I don't know who's good. always happy to support anyone else you guys enjoy watching, and it's always fun to meet some other people. Someone's doing some Game Maker's Toolkit game jam. That would be fun. Gauntlet before the final boss. Yeah. That's a really hard room. That's a really hard room, and it resets. Eligible release. Yeah, a bit older. I think definitely that's the wrong age. Original release. The final mix is really similar to the original release in a lot of ways. But just different enough. It's superior. It's a good little fix up to a couple of weird things. Just has a couple of good abilities. It's good. It's good. Someone's making a game about dog walking. That might be fun. I think they've been streaming for 3 hours, so maybe near the end. Infinite Coder. Let's do Infinite Coder. Let's see what Infinite Coder's up to today. Throw a raid over their way. Let's show Infinite Coder some love. Thank you everyone who's been on this journey. I do hope to do some more stuff here and make a cool video talking about all the work I did off camera. So thank you very much for tuning in. I'm Tom, and I will catch you next time. Bye.